Hello everyone, my name is Thomas. I'm the CEO of TensorTech. So today I'm very happy to share with you about what TensorTech is doing and also the motion control solutions that we are offering to the space market. So first of all, what is the attitude determination and control of the satellite? So basically you can imagine all satellites in space that are floating in a zero gravity environment, that their solar panel need to be pointed to the sun in order to generate solar power, or their camera needed to be pointed to a certain location on the Earth to be able to capture pictures. So our product is to help people to execute tasks like this in order to do the full functional of the satellites. So a bit background for you about TensorTech. We were founded in 2019. It's almost 5 years from then. And we have got our first flyer heritage since 2022 January. And then since then, we have been delivering more than 100 suites of ADCS products, and also including components and also subsystems to the market so far. And we've been serving clients worldwide, including people in the commercial sectors, such as system integrator of the satellite, or even the operator of the satellite, who also integrate their own satellite systems, so that they will need subsystem providers like TensorTech, or even component suppliers like TensorTech, that they have their own team to integrate those components into a subsystem to be functioning inside their satellites. Besides that, we also get government users that across the globe, including the one in Taiwan, the one in US, one in the Europe. We all having users in those governmental sectors. And lastly, there are also academic users who are building their own CubeSat or even microsats that is aiming for space education or even for their scientific research purposes. So if we zoom into the range of the ADCS product that is offered by TensorTech, you can see the first series is the so-called integrated system, which is a subsystem of the ADCS. That means we already put together all the sensor, the actuator, and also the software together to offer a user a plug-and-play system that they are able to use them directly onto their satellite system without the need to program those complicated ADCS system dynamics and control law estimation algorithms. And the second series of our product line is the component series, that we are offering the fine-sun sensor as individual components, or like Magnetorquer as an individual components, or even the Control Moment Gyroscope as a component, which is a unique technology in TensorTech that is drive the satellites to do motion control via not only single axis motors, but a multiple axis actuators that are able to have advantage such as torque to power ratio, etc. And the third one is our ADCS TestBed, which is a equipment that we developed initially to do in-house functional testing of our component or our own system. But now we are offering it to the market for the users who need to do the functional test of their spacecraft on ground. And that are the services for the users. That basically what we provide is a motion control solution that we help the people to put together a suitable component and select suitable subsystems, and using appropriate testing methodologies to deliver the results that the users anticipate, and help them to solve the problem, send objects to space. So if we zoom into this ADCS subsystem product here, you can see it is actually designed for a 3U CubeSat, and it contains components such as the fine-sun sensor, the black object here, which is be able to get the sun vector of where the sun is, and also it contains magnetometers inside that are able to measure the Earth's magnetic fields in the local region, and also the CMG in the center, which provide torque to the satellite that drive the satellite to spin and to orient itself to the position that is commanded by the user. So when using these ADCS module, the user can just input with simple command such as Earth pointing or sun pointing or even target tracking, that they just give us these simple commands, and the ADCS will control the satellite to follow those commands that is given by the user. And inside these ADCS systems, there comes to our Control Moment Gyroscope, which is a core technology of TensorTech. So like reaction wheels, these CMGs are also angular momentum exchanging devices, but just they have more degrees of freedom than traditional reaction wheel does. That allows us to utilize the gyroscopic torque from those actuators and be able to make the torque to power ratio of these CMG and ADCS systems to be 10 times compared to the system that is using traditional reaction wheels. And the third one is our fine sun sensor here. You can see this is actually quite small. That is very thin, very small. So you are able to put multiple of these sun sensors on the surface of your satellites so that you can get sufficient field of view of the sun is. And also you are able to use the digital interface within so that user can just send a request to the sun sensor and it will automatically get you the responded sun vectors for you. And then you can also find that every sun sensor that we provide to the market actually gets a unique lookup table, a unique calibration matrices that we do it in-house before we ship and deliver every sun sensors, so the user can already have a very precise sun vector information without a need to do further calibration by themselves. And that's not all, that within these sun sensors that also comes with 3-axis magnetometers, so that you can also get the Earth's magnetic field information from this sensor node. Besides this, we also get our core sun sensor here, which comes with only one single axis of the sun vector information. And it is simpler, robust, and also smaller in size in this form factor, so you are able to deploy multiple of them on the surface of your spacecraft. And then also it comes with different electrical interface such as SMT or even the Molex connector here to help the user easily select the interface that they need for their spacecraft. And there comes to our ADCS testbed, which is in fact consists with 3 major sub-equipment, which the user can actually acquire them individually, like including the solar simulator with AM0, air mass 0 spectrum, and also spherical air bearing platform that provides 3-axis frictionless environment for the users to test the altimeter and also the controller of the ADCS, and also a Helmholtz cage that contains dynamic modes that allows the user to just input the orbit parameters, and we will propagate and calculate what is the local Earth's magnetic field should be and use it to serve as an input to the ADCS system, and therefore the attitude determination function within these ADCS are able to continually functioning. And so with this ADCS testbed, the user can basically create an environment that is similar to what the satellite will actually experiences in orbit and be able to find the fault earlier and to be able to find the bugs within your software or the way you command ADCS earlier, and to make sure all the parameters that you put into the ADCS is accurate and is not having priority issues or even other settings issues. So the next one, let's zoom into our ADCS computer, which is actually the core of our ADCS system that is served as the brain of it. So it will acquire the readings from all the ADCS sensors there, like the sun sensors, like the magnetometers, like these GNSS receiver. All the information gets into this ADCS control board. And besides that, the command from the user also gets into this. For example, the attitude control commands, what orientation you wanted the satellite to align to right now, or the target that you want ADCS to tracking to, such as the sun, the earth, or even a target, a terrestrial object that is, its coordinate on the surface of the earth. And Besides that, it will also send commands to the rest of the actuator on board the ADCS, including our Control Moment Gyroscope. These are the in-house products, the Magnetorquers, and also even these ADCS computer, the brand of it can also connect to some third-party components such as the star trackers that is off the shelf on the market that you can acquire from it and connect it to the ADCS computer. So next one is our DynaSense. This is the attitude determination module for satellite ground equipment. Whenever you need and your devices to know where its orientation is right now in order to do experiment on the ground or to do calibration or to do ground testings on ground, that you can use this module for you to determine the orientation of your devices on ground, which is also based in the same brand of the ADCS computer and also the same suite of the software. And lastly, let's see our Magnetorquer series of products. That is also an actuator for the satellite. That it comes with different form factor, different range of magnetic dipole moment. That it's basically input with currents, and then the magnetic substances inside and coil inside will generate a dipole moment there, and therefore your satellite can experience a torque that is generated by these currents and these magnetic field within these torquers. And then besides this largest one, we also have the smaller form factor that comes with a Magnetorquer board. That's two rods, torque rod like this is embedded within the board, and as well as the driving circuits. And then these torque rods comes with standard form factor like this, and with different sizes, and also the Magnetorquers that are customized for the users to fulfill the mission requirement of their spacecraft. So this is all for you about TensorTech, and also a brief introduction for you about the range of products that we are offering to the market right now. And I hope you enjoyed. Thank you for your time today.